Hi guys, it's Mrs. Tucker. Get out your growing trees placemat. This is the one we're going to do next. All right, it says verbal representation. A tree that is 2 feet tall grows at a rate of 1 foot per year. Okay, I go down to the Houston Garden Center, I buy myself a little tree, and this little cute tree, it's 2 feet tall. It looks like this. It's 2 feet tall. And the moment I planted it in the ground, here's ground, the moment I planted it in the ground, that's times 0. How tall is my tree? Yeah, it's 2 feet tall. Now, after 1 year, if it's growing at a rate of 1 foot per year, how tall is my little tree? Yeah, after 1 year, it's 3 feet tall. How tall is it after 2 years? It grows a foot a year, it's 4 feet tall. Finish filling out this column here, and I'll pause the video and wait on you. Okay, does your column look like my column? Great. Now we got to figure out our process or our rule. Okay? I need to know, what are you doing to this number to change it into that number? Well, let's look for the patterns. I noticed that my number of years is increasing by 1, and ultimately this year, any tables that you guys are doing, we want to make our column, this is going to graph on our x-axis, and we'll talk about that in a minute. Our goal is to make this column increase by 1 each time, because if you'll do that, it makes the rest of what we're going to do easy. Okay, so I'm going to look for a pattern over on this side. I start off at 2 feet tall at time equals 0, and by the first year, I've increased by a foot. And from year 1 to 2, I've increased by a foot. And from year 2 to 3, I've increased by a foot. 3 to 4, I've increased by a foot. Well, over that 4-year period, I've increased by 1, plus 1, plus 1, plus 1. Isn't that the same as taking 4 groups of 1 foot of growth per year, and that's 4? Yeah, so it has grown 4 feet, but the answer here is 6. Its total height is 6. Why is it not 4? What's going on here? Oh yeah, I forgot. It started off at 2 feet tall, right? It's 2 feet. I have to add on to, let me change this up. In addition to the 4 feet of growth, I started off at 2 feet tall, right? So that gives me 6. Well, what about back here? What about at 2 years? That's 2 groups of an increase of 1 foot per year. That's just 2, but they say the answer is 4. How did they get 4? Yeah, because this little tree started off at 2 feet tall. Do you guys see what your process is going to be? I think what we're going to have to do is take our 2 feet that it started off at and add, at this point, it's going to be 1 foot of growth over a 4-year period. That works out. Back here at 2, we started off at 2 feet tall. We had 1 foot of growth for 2 years, which equals, yep, that adds up. I want you guys to finish out your rule. Finish out this column and I'll wait on you. Does your table look like my table? Yeah, and some of you guys might not have put in the 1 foot per year, because you might have just put in the number of years, because 1 times any number is that number, and that's okay. Okay, now we've got to graph it. Let's give this thing a title. I'm just going to call it Growing Trees. I'm going to call it Growing Trees. So, I need to put my independent variable on my x-axis and my dependent variable on my y, and I have 2 variables. If you look at our process, these numbers are changing. Everything else stays the same, but those are changing. What are those numbers? Yeah, those are your numbers of years, and the other thing that's changing is our answer. So those are our 2 variables. So I got to ask myself, Does the number of years that the tree grows depend on the tree's height? Or does the height of the tree depend upon how many years it's been growing? Yeah, height depends on the number of years it's been going. So number of years is going to go down here, and your height in what units? In feet is going to go right here. All right, so get that labeled. And I always want your graphs to start at 0, 0. All right, for your number of years, and where'd my table go? Number of years has to go from 0 up to 10, and you have to increment by the same amount each time. Am I going to go 5, 10, 15, 20? Oh, no, no, no. Am I going to go 2, 4, 6, 8, 10? No, let's spread it out as much as we can. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's do that. Let's scale it out that way. Make your scale look like that. All right? Our total height at 0 was 2. When we got down to here, it was 12 feet tall. So I actually told you guys I want you to start at 0. You have to go from 0 to 12 on your y-axis. Can we make each line worth 1? Well, let's check it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, let's do that. Okay, I'll give you a moment to scale it out, and then start graphing your ordered pairs. Okay. When at 0 years, our height was 2 feet. You ought to have a dot right there. After 1 year, it's 3 feet tall. Your next dot goes there. After 2 years, it's 4 feet tall. Your next dot goes there. Graph your ordered pairs, and I'll wait on you. I'll pause the video. Okay, did your graph look like that? Good. The next thing I need to ask before we leave the graph, do we connect the dots? And to answer that question, you're going to ask yourself, is there X and Y data in between all of the whole numbers? Can the tree have grown for 3.5 years and have gotten to a certain height? Yes. Yeah, it does. It continuously grows throughout time. So since the answer to that question is yes, you'll connect the dots with a straight line. And if it's a straight line, I want you to use a straight edge. The side of a card, a ruler, the side of a spiral notebook, use something straight. Okay, let's go write an equation. Okay, I noticed in my process the 2 always stays the same. The plus always stays the same. Multiplying by 1 always stays the same. You can put that in your equation or you can leave it out. 1's that special number. Okay, what changes is this right here. And what changes is our total height. So I need a variable to represent years and height. You might use Y for years, you might use H for height. Since the number of years graphed on the x-axis, some of you guys might want to use X. Since total height graphed on the y-axis, some of you guys might want to use Y. Okay? It's up to you. I would put Y here and H here if I went that route. I said let Y equal your number of years and H be your height. And I know that 2 plus my number of years equals my height. Is it okay if I do this? 2 plus 1 times the number of years equals a height? Yeah, that's fine. Is it okay if I say Y plus 2 equals height? Yeah. What if I turn it around and say H equals 2 plus Y? Yeah, all of those are fine. What if I used X and Y? What if I say Y equals 2 plus X? All of those work. Okay? Now let's answer some questions. Okay, how tall will the tree be in 13 years? Well, some of you might want to go ahead and add a three more rows onto your table. Let's see, that was 12, this would be 13, this would be 14. It'd be 14 feet tall, and it says, which representation did you use to answer your question? If you did this, you would say, I added a few more rows to the table. Some of you might have extended your graph out. Some of you might have said, well, the height of the tree is 2 plus the number of years, and the number of years is 13. So the answer is 15. What did I do wrong here? That's 12. Oh. 10 is 12. 11 is 13. 12 is 14, and 13 is 15. I kind of skipped a line in there, didn't I? Yeah, I kind of messed up there. Whoops! But I fixed it. I found my mistake. Okay, now answer this question. How long will it take for the tree to be 12 feet tall? All right, you answer that question.